Okay, perfect. Thank you very much, Sarah. Okay, yeah, so my name is Danny White. Tuning into hydrology days in this format is kind of unique, but I'm still happy to be able to present and grateful for those that have spent some extra time preparing for the online webinar, so thank you. A little bit more about myself. I'm a PhD student. I'm working with Dr. Ryan Morrison in the Department of Civil and Environmental Engineering. And the project that I will speak about now was carried out in conjunction with Dr. James Roberts, who is a fish biologist for the USGS. And he has extensive experience analyzing the impacts of climate change on Western native trout species, and it has been a pleasure working with him. Let's see here. So I felt that it would be appropriate to kind of introduce the Colorado state fish and provide a little bit of background information on its recent history of presence or lack thereof in Colorado rivers. The Greenback Cutthroat Trout, or Oncorynchuss, clarkii, stomias, is one of only 2 native trout species that are found east of the Continental Divide. The other is the Rio Grande Cutthroat Trout. The Greenback Cutthroat Trout is native to the upper South Platte River Basin within the southern Rocky Mountains. Greenback Cutthroat Trout were thought extinct in the 1930s. However, in the 1950s, a presumptive pure strain was found and recovery efforts began. The greenback was federally listed under preliminary endangered species legislation, which was in 1966. And then when the Endangered Species Act was passed in 1973, the Greenback Cutthroat Trout was also listed as endangered. The Greenback Cutthroat Trout became the Colorado state fish in 1994, and about at the same time, efforts to reintroduce the fish were underway throughout the Front Range. In 2007, though, it was discovered that many of the populations that were restored to the landscape had genetics that originated actually west of the Continental Divide from a subspecies called the Colorado River Cutthroat Trout. Further genetic analysis using museum specimens led to the discovery that there was actually only one single population of pure strain Greenback Cutthroat Trout that remained. And that population was outside the South Platte River Basin near Colorado Springs in the Arkansas River Basin. That remnant population in Bear Creek has been used to propagate the genetically pure cutthroat trout that is native to the South Platte River Basin. Although morphologically similar to other cutthroat trout native to Colorado, unique traits have been identified that set it apart. And despite similar genetics to other strains and a small remnant gene pool, biologists and managers are continuing their efforts to preserve the Greenback Cutthroat Trout and establish populations in its native range. So the Greenback Cutthroat Trout, as I said, is currently federally listed as threatened under the Endangered Species Act. And this listing is largely due to competition with non-native species, hybridization, habitat loss and fragmentation as a result of hydrologic alteration. And following recent recovery efforts, there are actually only 4 populations of Greenback Cutthroat Trout that exist in the wild, and they occupy only 14.5 kilometers of stream and 4 hectares of lake habitat. Brook trout, a species native to the northeastern United States, were introduced to streams in Colorado in the 1800s and remain a managed sport fish in many parts of the state. Brook trout are able to outcompete native cutthroat trout as fall spawners that spend nearly an entire year as fry growing large enough to survive low flow and cold water temperatures through the winter. As spring spawners, cutthroat trout fry are a lot smaller, and they are often unable to compete with brook trout in headwater streams. Removal of brook trout and subsequent introduction of greenback cutthroat trout has taken place in recent years to establish more populations on the landscape. Although there is significant effort to quickly restore populations to the streams that have been identified as suitable, there is still much uncertainty regarding the long-term habitat quality under future climate change scenarios. Besides the greenback cutthroat trout, there are 4 other native subspecies, including the Rio Grande, the San Juan, the green lineage Colorado River cutthroat trout, and the blue lineage Colorado River cutthroat trout, which you can see in this figure here. You also see that here in the Arkansas River drainage, there historically was a native cutthroat trout called the yellowfin. However, it is no longer in existence. High elevation montane environments are often referenced as highly sensitive to the effects of climate change due to the island-like geographic nature of available habitat patches. With a rise in temperatures due to climate change, these habitat patches are projected to decrease. However, recent studies have shown that cold water systems at high elevation headwaters have proven to be resilient and provide refugia in the face of rising temperatures. And that data can be found in this Isaac et al. Paper, 2016. The rate at which temperatures rise and available habitat decreases is often referred to as a climate velocity. Using a large data set of cold water systems in the United States, including the period of warming since 1968, Isaac et al. Have shown that strong local temperature gradients associated with topographic controls have actually slowed climate velocities. And as such, during this century, montane cold water streams will likely serve to buffer the effects of rising temperatures. However, it is well documented that with an increase in temperature and changing climate, the hydrologic regime of streams will be strongly altered. As such, not only the effects of increased stream temperature must be assessed to determine the persistence of native fish populations, but a decrease in stream flow essentially results in a decrease in available habitat for native trout. As discussed by Roberts et al. In 2017 and Wenger et al. In 2011, conservation of cutthroat trout native to the Rocky Mountains will require estimating effects of multiple stressors and managing those that most heavily impact habitat availability and quality. Non-native trout, including brook trout, continue to compete with greenback cutthroat trout and reduce available habitat. As shown in this figure here, you can see that for not only native cutthroat trout, but other trout species, habitat availability as measured in length of suitable habitat will decrease under future climate change scenarios in the 2040s and 2080s. So especially with a species with sensitive conservation status, such as the greenback cutthroat trout, taking effective management actions to mitigate for the effects of climate change and other drivers is critical to ensure their continued existence. Despite management efforts that are currently underway, much is still unknown about what stream and lake characteristics could help maximize the efficacy of greenback cutthroat trout reintroduction efforts. To effectively plan conservation strategies, we need to identify suitable habitat distribution across the landscape and relative metrics, including flow, temperature, depth, etc., and what that habitat will look like in the future and how climate change effects will be felt range-wide. So to do this, we have conducted a range-wide habitat survey, and we selected the 4 streams with existing populations of greenback cutthroat trout, as well as 8 high priority sites where they may be reintroduced in the future. The sites range as far north as George Creek, a tributary of the North Fork of the Poudre River, all the way down south to near Colorado Springs, Bear Creek, where the last existing pure strain greenback cutthroat trout population was found. And the sites that we surveyed range in elevation from 1950 meters to 3650 meters. All of the sites besides Bear Creek were located in the South Platte River Basin where the greenback are native. So to perform our channel geometry surveys to characterize the habitat, we used an auto level and a stadia rod. But before doing that, we identified reaches of these streams that have gradient and habitat that is characteristic of the entire catchment. We also selected reaches that would be suitable for surveying with an auto level and stadia rod. Some were inaccessible. For example, we stretched a longitudinal channel station measuring tape and established 10 roughly equally spaced cross sections and recorded their location. We left an inconspicuous wooden stake if we do need to go back and survey any of our 10 cross sections or any of our survey sites again. So further metrics that we collected or measurements were flow, and we used, as you can see here in this picture, a flow tracker 2, which is made by Sontec. In 2019, we took one flow measurement at each site, and in 2020, this summer, we plan to go back and take 4 to 5 different flow measurements at a variety of stages. And we installed temperature and pressure loggers and sensors, and we used the onset hobo. And we deployed those in 2019, and they will continuously read data through 2021. With the data that we collected from the channel geometry surveys, we built hydraulic models in HEC-RAS. We needed a simple backwater modeling software that would provide outputs such as depth, weighted perimeter, and velocity that would help us to determine and identify which streams had suitable habitat. The preliminary results, or the data that we collected from last year and are processing currently, include 1D HEC-RAS models that were calibrated from the one flow measurement that we took in 2019, continuous pressure, transducer, and flow stage data, temperature data, and we also have looked at the projected flow metrics for survey sites, and this is based on a variable infiltration capacity macroscale model, and that is available at the Western U.S. Streamflow Metrics dataset that's made available by the U.S. Forest Service. And those projections include hydrologic metrics such as the 1.5-year return interval, et cetera, and I'll talk about that here in a second. Here are just a couple of examples of some of the, results, you could say, from the 1D modeling and the calibration that we have done so far. This is a site located, the figure here on the right is Corral Creek, which is a site located in the Upper Poudre watershed near Long Draw. And then here you can see the calibrated model that correctly matches or closely aligns with the measured water surface elevations. Continuing here, a couple of more 1D HEC-RAS models that we built and will use and continue to calibrate as we collect more flow measurements. And here are some of the flow or the pressure sensor data that we have collected during the summer of 2019, and more will come in, and we will be able to use that to, using a stage discharge curve that we develop, will, from the pressure data, be able to calculate the discharge throughout the year. So some of the metrics that we want to look at that are projected in this VIC hydrologic model include the mean annual flow, the mean summer flow, mean August flow, the 1.5-year return interval flow, and the center of mass flow and timing, as well as the baseflow index. Here is a table of some of the things that are interesting, and this is for the hydrologic projection in 2040. We can see that there is a negative 40% roughly decrease in some of these streams for the mean summer flow. And then we also see that this CFMD stands for essentially the center of mass, or the day on which the majority of the flows happens in a given stream. So this negative 17 indicates that the flows will, runoff will happen earlier in the year. Some further data, and then what we're really seeing is that low latitude streams see the largest decline in mean annual flow. High elevation streams see reduced summer flow, and then mid elevation streams see the least overall percent decline in hydrologic flow metrics. So we can see that there are spatially distributed effects of climate change. And using this data, using the 1D hydraulic model, as well as these 2040 and 2080 hydrologic projections, we will be able to assess habitat quality going into the future. We will also take some of this abiotic as well as some biotic interaction and drivers for persistence of native cutthroat trout species. A Bayesian network is currently being built by James Roberts, where he will take in a lot of these parameters that we measured in the field and be able to statistically describe the probability that greenback cutthroat trout will have persistent populations at each of these survey sites going into the future. And that's it. Are there any questions?